Welcome to The Explainer. We're all constantly amazed by what these large language models can do. But here's the thing. The real magic isn't just building a brilliant AI, it's keeping it brilliant. Today, we're diving into LLMOps. That's the crucial, behind-the-scenes work that keeps these incredible AI systems sharp and effective out in the real world.
And that brings us to the big puzzle, right? If these models are so incredibly powerful and intelligent, how is it that a model that was once at the top of its game can slowly, lose its edge? Why do they start making mistakes?
Just look at this. This is such a classic story. At launch, your model is an absolute rock star, maybe hitting 95% accuracy. But then, the world doesn't stop. The kind of data it sees changes, language evolves, and without any help, that once brilliant model starts to slip. That drop-off, that's exactly what we call model decay.
So here's our game plan for today. First, we're going to dig into the problem itself. Then, we'll look at the old playbook, MLOps, and figure out why it's not quite enough for these new LLMs. From there, we'll jump into the new rules of LLMOps, and finally, we'll wrap up with what all this means for the future of working with AI.
Okay, let's get right to it. What is actually causing this decay? Let's get to the bottom of why these brilliant AIs can fail.
It really boils down to two main troublemakers. The first one is called data drift. This is pretty straightforward. The data the model sees out in the wild just isn't the same as the data it was trained on. But the second one, concept drift, that one's a bit sneakier. This is when the meaning of the data itself changes. The words are the same, but the ideas and concepts behind them are brand new.
Okay, so we know the problem. How have we usually dealt with this? Well, to get a handle on the new playbook, we've got to understand the old one, MLOps.
So what exactly is MLOps? Well, it's pretty much what it says on the tin. It's a whole set of practices focused on one main goal: creating a smooth, automated, and reliable way to get models out into the world and, this is the important part, keep them running well. The easiest way to think about it? It's basically DevOps, but for the world of AI.
The classic MLOps approach is to build this automated pipeline around the model. It uses CI and CD to reliably test and deploy new versions. It has continuous monitoring to keep a close watch on performance. And the hero of our story so far, it uses continuous training to automatically retrain the model and fight back against that decay we talked about.
And this has worked great for a while. But here's the kicker. Large language models, they are a whole different animal. The scale, the data, the parts that make them tick, it's all just on another level. And that means the old MLOps playbook, it just isn't enough anymore. It's time for an upgrade.
Just look at the difference here. On one hand, you have traditional ML, which is all about managing code that deals with nice, clean, structured data. Rows and columns in a spreadsheet. But with LLMs, forget it. You're swimming in a sea of messy, unstructured text. And all of a sudden, new things like the quality of your prompt or the freshness of your external data become absolutely critical.
So here's the bottom line. The models are different. The data is different. All the moving parts are different. So the way we manage them has to be different. This new specialized approach is what we call LLMOps.
All right, so this brings us to the new rules of the game, LLMOps. And to make this super clear, we're going to zoom in on one of the most popular ways people are actually doing this right now, out in the real world.
So what is LLMOps really? You can think of it as the evolution of MLOps. It's the new toolkit, the new set of processes designed specifically for this kind of chaotic, text-filled world of LLM applications, managing them from the first idea all the way to production and beyond.
Let's check out this really clever technique called Retrieval Augmented Generation, or RAG for short. This is an awesome way to keep an LLM sharp and reliable. See, instead of relying only on its original training data, which could be months, even years old, a RAG system does something smarter. It first goes out and grabs fresh, relevant info from an external source.
It's a beautiful two-step dance, really. It's so simple but so powerful. First, when you ask a question, the system retrieves up-to-the-minute information from a trusted knowledge base. Then it takes that fresh context and hands it to the LLM to generate a way more accurate and grounded answer. I absolutely love this quote because it just nails the core idea here. You can't treat these things like a book you buy once. To be useful, an LLM application has to be a living, breathing thing that you constantly keep updated with fresh information. This table just makes the why behind RAG so clear. Look at traditional fine-tuning. The knowledge is baked right into the model's core, which makes updates super expensive and complicated. But with RAG, the knowledge is kept separate and dynamic. So if you want to teach it something new, you just update the external knowledge base. You don't have to retrain the whole billion-parameter model. It's just so much more agile.
Okay, so keeping your data fresh with something like RAG, that's a huge piece of the puzzle. But LLMOps is about more than just that. Let's touch on a couple of other super important ideas for managing the entire lifecycle of these models.
First up, something that honestly sounds like it's straight out of a sci-fi movie, machine unlearning. Just imagine you need a model to forget something it learned. Maybe it's user data you have to delete for privacy reasons, or some bad info that's throwing off its answers. Machine unlearning is like performing surgery on the model to carefully remove that data's influence without the insane cost of retraining the whole thing from scratch. It's absolutely critical.
And then there's lineage tracking. Seriously, if your AI gives you a bizarre answer, how do you even begin to figure out why? Lineage tracking is all about creating a perfect audit trail for your AI. A complete paper trail for everything from the data and code to the experiments and the final model. That kind of traceability is the absolute bedrock of building AI you can actually trust.
And you know, all of this leaves us with a final thought. For years, the whole game has been about building bigger, more powerful models. But as these incredible AIs become a part of our everyday lives, maybe the real frontier, the hardest, most important challenge, isn't just building them anymore. Maybe it's the day-to-day, sometimes unglamorous, but absolutely vital work of running them safely and effectively in the real world. Something to think about. Thanks for joining me.